Let's look at the behavior of graphs. Now, we look at a graph in a certain language in order to describe what we're looking at, as well as communicating to others. So we need a common language. With agreed upon meaning, we will consider two basic concepts in describing a graph. And here's the first one: increasing and decreasing. When we look at a graph, we determine if the dependent variable, which is really the, what we call in general terms the y variable, is going up, which is increasing, or going down, which is decreasing. And to do this, we need to agree that when we determine if the graph is increasing or decreasing, we will read or visually move on the horizontal axis from left to right. Okay. And we usually describe when it is increasing or decreasing by using an interval notation. If the graph is not increasing nor decreasing, as we increase the horizontal variable, then we say the graph is constant on that interval. Okay. And here's a kind of a definition of, let's say, let's choose increasing. And I'm going to draw a little graph here just to help out in the definition. So when you see definitions, it's usually helpful to draw a big picture, if possible. And I'm going to make this straightforward as I possibly can. And I'm going to mark 2 points here, x1 and x2. And you can see that these are related to, it's not y, but this is f of x1, and this one, let's see it right here, and that's f of x2. So a function is increasing on the interval let's say the interval here is going to be a, b. So again, notice this is the interval I'm talking about, a to b. If for any x1, x2, again, I just put these arbitrarily inside this interval, such that x1 is greater than x2, sorry, backwards, x2 is greater than x1. So again, this is what allows me to move from left to right, If as long as x2 is bigger than x1, we have that. And now I'm going to read my chart. It looks like f of x2 is bigger than f of x1. And that's what we mean by increasing. Decreasing is the exact opposite. I'm going to do it without writing the words down. But again, here's our interval a, b. And then I'm going to graph out and make it simple. So again, this is going down. And again, I'm going to draw my x1 and my x2. And I'll follow it over here. This is f of x1. Follow over here. This is f of x2. And again, we have that x2 is greater than x1. And this now implies this little arrow means that this then follows or implies. And now we have the exact opposite. We have f of x 2 for all these values is less than f of x 1. So now we reverse. F of x 1 now is greater. And that's what we mean by decreasing. Right. So on what intervals is the shown graph increasing, decreasing, or constant? So let's look at what is this domain. So the domain here looks like a negative infinity, and it ends here at 10. All right. So as I'm coming here from negative infinity, I see that this graph is having no change. There's no arrow here, and it goes on forever, but for these type of graphs that are done in the computer, that's where you can put some. It's coming in that direction forever. And it stops, looks like, at -5. So coming from infinity all the way to -5, we are constant. So this function the function is constant. Oops. And again, I have to describe an interval, so going from negative infinity all the way to 10. No, -5. And notice I must use open parentheses, meaning I cannot use this is no good. If I were to write something like this, right, that is no good. So no good. I got to use an open parenthesis. I cannot include the -5. And the reason is, you can see, is because I'm going to need the -5 to describe decreasing in a minute. So I cannot include, if I include the -5, then where does the -5 belong to? In reality, it doesn't belong to anywhere. We're describing one interval, the graph is doing something. In this case, constant. What about decreasing? Well, the function is decreasing. On, and now you see right here, starting at -5. So again, open parentheses, -5, because that's where it starts, but I can't include it. I want to describe an interval where this is happening. And it looks like as I'm going from left to right, reading, right, from smallest to largest here, I am going down, down, down until I reach 0. And again, I cannot include 0. But then later on, I can see that 6 is 2, 4, 6, 8, yep, 2. So at 2 and ending at 4, it looks like, I start to go down again. I'm here, I'm at the high point, and I go down until I reach 4 and it gets to this low point. So it's also decreasing on 2, I mean interval 2 all the way to 4. Again, notice don't include. And then I'm going to use the union symbol to connect these two intervals. So it's decreasing on these two intervals. Anywhere else? No. And now we have also the function is increasing on what? Well, let's see. It's increasing on, well, look, it's starting on at 0 and going all the way to 2. It's starting to go up. So as I'm going from left to right, reading, see the y values going up. They're increasing. Where else? Well, right here as well, starting at 4. As I'm going from left to right, going 4, and on the axis, I'm going reading from left to right, starting at 4, and then going up, 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 up. I reach this bump, but I continue to go up. And in fact, I continue to go up until I reach 10, and then it stops. I notice again, I'm not including 10. I know there's a little solid, I'm not sure I include that, but no. I want to describe where is increasing, and we don't include the endpoints when doing this type of description. So here's where the function is constant, decreasing, and increasing, and we describe everything using interval notation, and then I have to unite these two intervals. So I use my unit summary.